Reducing complexity of exception handling in code. Exceptions are a fundamental part of error handling in code. However, excessive or poorly designed exceptions can lead to complex, hard-to-maintain code bases. Here, we'll explore strategies to reduce exception complexity and design clearer, more user-friendly interfaces. As software systems grow in complexity, managing exceptions and maintaining clear, easy-to-use interfaces can become a significant challenge. Excessive exceptions and complex error handling can make code harder to understand, debug, and maintain. Here are some strategies to reduce the complexity and number of exceptions in your code, leading to clearer and more user-friendly interfaces. 1. Simplify exception handling. One of the primary ways to reduce complexity is to simplify exception handling. Instead of catching and handling every possible exception, consider grouping related exceptions into broader, more generic exception types. This approach can help reduce the number of catch blocks and make the code more readable and maintainable. For example, instead of catching specific exceptions like file not found exception, IO exception, and security exception, you could catch a more general file system exception that encompasses all of these. This way, you can handle the common logic in a single catch block, rather than duplicating code across multiple catch blocks. 2. Minimize exception propagation. Avoid propagating exceptions up the call stack unnecessarily. Instead, handle exceptions at the appropriate level of abstraction, where you have the necessary context and information to provide a meaningful response. This can involve converting specific exceptions into more generic, higher-level exceptions that are more appropriate for the current layer of the application. By minimizing exception propagation, you can create a cleaner, more cohesive interface for your code, where callers only need to handle a few well-defined exception types, rather than a long list of potential exceptions. 3. Use checked against unchecked exceptions wisely. Carefully consider when to use checked and unchecked exceptions. Checked exceptions require the caller to handle or declare them, while unchecked exceptions, such as runtime exception, do not. Overusing checked exceptions can lead to a proliferation of exception handling code, making the interface more complex and less user-friendly. As a general guideline, use checked exceptions for exceptional conditions that the caller is expected to handle, such as file not found or network connection issues. Use unchecked exceptions for programming errors, such as null pointer deferences or invalid arguments, which the caller is not expected to handle directly. 4. Provide meaningful error messages. When throwing exceptions, make sure to provide clear and informative error messages that help the caller understand the problem and how to address it. Avoid generic, unhelpful messages like an error occurred or something went wrong. Instead, include relevant details about the specific issue, such as the affected resource, the expected behavior, and any additional context that can help the caller resolve the problem. 5. Implement a consistent exception handling strategy. Establish a consistent exception handling strategy across your codebase. This can involve defining a set of custom exception types, guidelines for when to use them, and a standard approach for logging and reporting exceptions. By having a consistent approach, you can make the code more predictable and easier to understand for both developers and users. 6. Leverage exception handling frameworks. Consider using exception handling frameworks or libraries that can help you manage exceptions more effectively. These tools can provide features like centralized exception handling, automatic logging, and the ability to define custom exception types and policies. Examples include Spring's exception handling mechanisms, Java's java.util.logging package, or third-party libraries like SLF4j and logback.by. Following these strategies, you can reduce the complexity and number of exceptions in your code, leading to clearer and more user-friendly interfaces. This can improve the overall maintainability and robustness of your software system.